we will create a ECS cluster and we will deploy a Node.js React application on that cluster. Okay, again we will use Terraform for that. Just like CloudFormation, Terraform is another tool to do infrastructure as a code. So first what I will have to do for that is this. So this is the React app. It looks something like this. So we are going to deploy that. So what we have to do for it, in the beginning we have to create the Docker image for this one, this React app. We will push that Docker image to ECR. So ECS is just like a framework, just like Kubernetes. It is an orchestration framework which can pull Docker containers from a registry and run them, and it can load balance them also. Okay, so let's do that. So first step, let's create a Docker image of this. So again same, you have to download this zip, unzip it or git clone it. Okay, and then once you do that, go to that folder. This is that color test master. That is a simple React app for coloring a page. So it's just a demo. So this is the repo which has various files. These are all the Node.js related files, package.json and everything inside the public. Docker file is what contains how to build that Docker image. So let's build that Docker image. So how to build that? Docker build -t, that's the tag of the image. So I have also written it here as a comment so that you don't have to worry. So, and also don't make mistakes in the spelling and all when you are trying this POC. So just Docker build tag name, the name of the image, and dot. So this dot means in the current working directory you are taking all the files and creating Docker image. Okay, so this is what we are going to do first. But when it builds the image, now this image will stay inside your local machine. Okay, not in the AWS. So how to send that image to AWS? That is our next step. So image is built, but this is in my laptop, not in the AWS. So how AWS will deploy to ECR? To do that, let's go to AWS and we will search for ECR, Elastic Container Registry. So you store all your Docker images in container registry so that Amazon services can be able to access the image. So we are going to create a repository. Get started. Make it private because say in production you will be doing this as a private image. And repository name, we can name it workshop and nothing else. Create it. So here you can see it has created a repository called this workshop. Okay, and if you click here you can see there is no image. We have to push that image. So how to push that image? It's very easy. You just click on this view push commands and you will see all the commands to push your image. Okay, so what I will do is just copy this and go back. You should have AWS CLI installed in your system, and then you will be able to run this AWS command. So this command is to log in into the AWS ECR, and then this command I have already done because I built that image in my local. So this is already done in my case. So now I am just trying to send that image into AWS. So I am doing the third command. This tags the image, and the fourth command pushes the image into AWS repository. So this one pushes the image there. So it will take some time to push that image into the repository. And once the image is pushed, we will create the ECS cluster. So how do we do that? For that, we have to go to this Terraform workshop repository. Those of you who are thinking like this is too much or getting too difficult, then just you have to revisit that video and see what I am doing. So when you do it at your own pace, you will feel like this is easier. But it's nothing. I created a image, then I pushed that image to Amazon ECR. Now I am creating a ECS cluster. Then I will put that image on the cluster and see that website. So that's the thing we are doing. And to do this, we will use Terraform to build that ECS cluster. So here again, all the steps are there and some notes are there. So how to do that? First, clone this Terraform workshop repository or download that zip file. And once you have downloaded it, go to that folder, Terraform workshop. This is that folder. So here I will see the Terraform files .tf. These are all Terraform files. Different files are for doing different things. One is for creating, just like CloudFormation. Here the main.tf is the main file that contains, defines what credentials are used to log into my AWS. So I have run that all here. What is the region I am using, what is my S3 bucket name, that is defined here. That's the main file. Then there is a variable file which is also important. There you define what is the name of the ECS cluster and so on. And then you have a ECS.tf that defines what are the ECS variables that are used. So ECS.tf, here is the name of the ECS cluster, what is the VPC, what is the security group, which port will be open. So all that is mentioned here. Okay. Spend some time on this file, read each of these resources and imagine what resource it is building. Okay, this one is building a cluster. Okay, this one is building a IAM role. This one is building a capacity provider. Like that, just go through it and also learn Terraform a bit so that you will be able to understand. Now, something important here is container definitions. So there is a file called containerdef.json where we are defining what is the name of the image. So just do a double check, whatever image we pushed, whether that is written in your file or not. 789.556, this one. Okay. 789.566. Okay, this is correct. Okay. Because sometimes when you create a new repository and your account is not matching, then this one will come out as a different URL. So you might get errors. So that's why I just check that. And here is the definition of how big your Docker container will be. CPU is 10, 256 MB RAM and so on. So that is enough. So just recheck all these things. And then to run Terraform, first command is Terraform init. Don't worry about the commands. If you miss them, everything is here. So don't worry about that. So I'll just run it. What does Terraform init do? It initializes all the things that are written in the Terraform files. So it initializes means reads those files, checks whether all the dependencies are there or not, and loads them. Okay, so that is what it does. Then you can do a Terraform plan. Plan is like a dry run. It is not actually doing it, but it will show you what it is going to do. So you can run that. Okay, when you are doing it for the first time, you can run a Terraform plan. it will take some time, and it will do an inventory what it is going to build and so on. So that is what it is doing. And once the plan is made, it will you can apply it if you are feeling comfortable with whatever it is trying to do. So what is the summary of the plan? It is trying to build 26 components and nothing changing and nothing is getting destroyed. So safe to do so. If something is there which is overlapping with it, it might destroy also. So you have to be careful in checking what is there. For us, there is nothing because we are doing a greenfield project, something new. So we are just creating. So after the planning, you do a Terraform apply. Once you apply, these things will be created automatically, just like CloudFormation. So what will it create? All these things that was planned. So what was planned, you can see so many things will create. If you do this manually, it will take a couple of hours. So it will create a VPC, it will create a auto scaling group in Amazon to auto scale. Like if load is more, it can auto scale that cluster. So it will create a log group, like where it will store the logs. It will create a capacity provider, like this is a function that will increase when load is more. So you can say when 85 is the target capacity, more than 85 CPU comes, then do a scaling. So these things are defined here. And here you are defining that what should be in your web cluster, what is the name of your ECS cluster and all that stuff. And there is in ECS there is a service that is created, that service controls which port it will listen to and so on. And in ECS there is a task definition that is created that controls what should be the different parameters to run that particular Terraform in ECS. Like in task definition, you define all the parameters required to run a particular service or a particular task in a ECS cluster. So that is defined here. And here different profiles that you have to run and so on, lots of information. So use that template only and make your changes only in the variables.tf file and in the main.tf file. Okay, so that will just allow you to get. So here it is asking us to whether we are sure to do that. So we are saying yes. So now it will start the creation. Okay, so meanwhile let's take some questions while it is creating, because this is again going to take around 5 minutes and we will be done if everything goes well. So if anyone has any questions up till now, you can ask.
Yeah, we have a lot of questions than before. Yeah,
we have already crossed the time also, but anyway, these things we had to cover. This is the last one.
Right. We try to close the questions because this is needed. So from Shiva again, do we have any dynamic blocks concept in CFT CloudFormation the way we have in Terraform?
Yeah, we have it. But why do we have dynamic blocks also? And CloudFormation is continuously evolving, like AWS is evolving it. But I am saying when you have matured as a DevOps organization, like you should be using Terraform. Why? Because it has many advantages. One is your application will be able to be very dynamic, as you said. For example, something changes, then it will be able to maintain the state and accommodate that change. And most important, like all the high level people like CTOs who take decision makers, they will always want every infrastructure to be able to move to any cloud, like multi-cloud or be portable. They will say, okay, we have a new client who is in Azure, we want to bring it to AWS. So in order to do that, you should stick to Terraform if you are doing good DevOps. because that way you will be very independent to do that.
Exactly. So I think CloudFormation is something like vendor lock-in. So if you
Exactly.
go, you would
It
like
is good. Yeah, if there is no plan of moving, then do it. But in Terraform also you get resources more also. Like when you're hiring a DevOps engineer, you will see people with Terraform, comfortable with Terraform, you will get more. So that is also another factor, because you
right.
in the end you need some people to execute them.
Exactly. So we have another question. Let's go here. Could you please explain a bit about code deploy? How exactly it work? Where our application will run? Will that behind the server? Containers taken
Okay.
by the AWS.
Okay. So for code deploy, what is happening? There are three things you have to remember when you are doing the AWS DevOps. For Jenkins, you have just a pipeline which does the commit, like pulling from the report, building it, and deploying. But in AWS, what happens? In code commit, it is a repository where you are committing. It's just like a GitHub. And code deploy is the phase where you are actually building and deploying it. And the code commit, code deploy, this entire process is being orchestrated by code pipeline. So three things are there in this repository, like in this DevOps tools. So code deploy is the phase where the code is on GitHub or code commit phase, and then it will build it. So there will be steps that will define if build is needed or not. For example, in our case where we did that HTTPS, welcome DevOps people or whatever, so there you did not need a build because it's just a matter of running in Apache server. So that was simple. But if it is a Java or something, then in the code deploy phase you have to write Maven build or to build that particular thing. Okay, so meanwhile we have seen that the Terraform is built. So let's go back and just check the ECR should have the image. It has the image, and ECS should have a cluster there because we created a cluster using Terraform. So go to cluster. Here you can see Terraform workshop cluster is there. One service is also running. Very good. And we go inside it. Web service is running. So if you go inside, you will see tasks. So in the Terraform, I mentioned I need 10 containers, 10 Docker containers, so that if 2 go down, I will still be up. So it has created 10 containers. Till now 9 is there, and I think 1 is still coming. So running count is 9 and desired count is 10. So we can have one more in some time. Okay, it is trying. It is not having a blank server to create the last one. So it is keeping on trying. When it will create the last server, it will create it. But since we have 9 and we have a load balancer, we will still be up. So let's see so how our website is working or not. So we will have to go and check where is our load balancer. So how do we check that? Let's go to details. Let's go to target group. There it will show like the load balancer URL, so we can go through that load balancer to check. So we have a target group here, Elastic Load Balancer. Here you can see load balancer. So if you click that, you get the load balancer console. And from that you can get the DNS name. But in a real world, you will be creating a Route 53 www.xyz.com, whatever your company name is, and create a CNAME with this DNS so that your website will open. But for now I am just opening this one. So this will take our traffic to that container where we are running the React web app, and the React app is up. it is interactive also. You can like, so it is working. It's not just a static page, it's interacting with you.